Hi, in this video, we will solve key trigonometric equations you must know for exams. Watch till the end to learn quick solving trick, and don't forget to like the video and subscribe to our channel. Let's dive into it. Now, question 1 says, if sec square theta plus tan square theta is equal to 3, what is the angle theta? So we are given that sec square theta plus tan square theta is equal to 3. If you recall, sec square theta is equal to 1 plus tan square theta. So we will substitute sec square theta as 1 plus tan square theta into our equation. So our equation becomes 1 plus tan square theta plus tan square theta equal to 3. Further, our equation becomes 1 plus 2 tan square theta equal to 3. Now at this point, we'll move 1 to the right hand side. So our equation becomes 2 tan square theta equal to 3 minus 1. So we have 2 tan square theta equal to 2. Now, to make tan square theta subject, we divide both sides by 2. And our equation becomes tan square theta equal to 1. So if we take the root of both sides, we have that tan theta is equal to root of 1, which is still equal to 1. So therefore, tan theta is equal to 1. So at this point, theta is equal to tan inverse of 1. And tan inverse of 1 is equal to 45 degrees. So therefore, theta is equal to 45 degrees. Let's take up number 2 question. Now, question 2 says, solve for the angle S in cos 2x plus sine s equal to 0. So we are given to obtain the angle S for cos 2s plus sine s equal to 0. Now, if we also recall that cos 2s is equal to 1 minus 2 sine square s. So anywhere we see cos 2s, we substitute it with 1 minus 2 sine square s. So our equation becomes 1 minus 2 sine square s plus sine s equal to 0. Now we can rearrange our equation. We have that this becomes 2 sine square s minus sine x minus 1 equal to 0. At this point, our equation looks like a quadratic equation. So therefore, we make some substitution. We say let y be equal to sine s. So therefore, we have this becomes 2y squared minus y minus 1 equal to 0. Now we have obtained a quadratic equation, and we have to solve it using factorization method. Now at this point, we will look out for two numbers. that their sum is equal to -1 and their product is equal to -2. So we have -2 and +1. So we know that -2 plus 1 is equal to -1, and -2 times 1 is equal to -2. So our quadratic equation becomes 2y squared minus 2y plus y minus 1 equal to 0. Now, if we factorize the equation, we have 2y open bracket y minus 1 plus 1 open bracket y minus 1 equal to 0. Now our expression becomes 2y plus 1 multiplied by y minus 1 equal to 0. So therefore, if we have a multiplied by b equal to 0, it is given that a is equal to 0 or b is equal to 0. So therefore, we have 2y plus 1 is equal to 0. So y is equal to -1 divided by 2, or y minus 1 is equal to 0, thus y is equal to 1. But recall that y is equal to sine x. This was our substitution in order to obtain our quadratic equation. Now, for y equal to 1, we have that 1 is equal to sine s. So therefore, s is equal to sine inverse of 1. So s is equal to 90. Also, for y equal to -1 divided by 2, we have that -1 divided by 2 is equal to sine s. So therefore, s is equal to sine inverse of -1 divided by 2. So s is equal to -30 degrees. So therefore, s is equal to 90, or s is equal to -30. Please, to this point, if this video has been helpful to you, please smash the subscribe button and like the video. Now let's take on question 3. Question 3 says, find the values of theta between 0 and 360 which satisfy 6 sine square theta plus sine theta minus 1 equal to 0. Solution. So the equation given to us is 6 sine square theta plus sine theta minus 1 equal to 0. So from here, we can substitute that let p be equal to sine theta. So the equation becomes 6p squared plus p minus 1 equal to 0. Now we have been able to express the equation in a quadratic form. So for now, we can solve this equation using the factorization method. So we look at for two numbers that their sum is equal to +1 and their product is equal to -6. So the two numbers are -2 plus 3. So the equation becomes 6p squared plus 3p minus 2p minus 1 equal to 0. At this point, we can factorize, and we have that this becomes 3p, open your bracket, 2p plus 1 minus 1 2p plus 1 equal to 0. Now we have been able to factorize, and the expression will now be written as 3p minus 1. So since we have the same expression in the bracket, we pick one, multiply by 2p plus 1 equal to 0. So if a multiplied by b is equal to 0, a is equal to 0 or b is equal to 0. So therefore 3p minus 1 is equal to 0, or 2p plus 1 is equal to 0. So we have that 3p is equal to 1. So p is equal to 1 divided by 3, or 2p is equal to negative 1, and p is equal to minus 1 divided by 2. But we should recall that we established that let p be equal to sine theta. Thus, for p equal to 1 divided by 3, we have that sine theta is equal to 1 divided by 3. So at this point, call here equation 1. In equation 1, since theta is a positive number, it tells us that sine theta is either in the first quadrant or in the second quadrant. For first quadrant, we have that theta is equal to sine inverse of 1 divided by 3. So theta is equal to 19.5 degrees. Also, for second quadrant, we have it that sine theta is equal to sine 180 minus theta. This will be equal to sine 180 minus 19.5 degrees. So sine theta will be equal to sine 160.5 degrees. So therefore theta is equal to 160.5 degrees. Now let's consider question 4. Question 4 says, solve the following equation: 6 sine square theta minus 5 cos theta minus 2 equal to 0 for 0 less than theta less than 360. Solution. Our equation is 6 sine square theta minus 5 cos theta minus 2 equal to 0. Recall that sine square theta is equal to 1 minus cos square theta. So therefore, anywhere we see sine square theta, we put 1 minus cos square theta. So our equation becomes 6 multiplied by 1 minus cos square theta minus 5 cos theta minus 2 equal to 0. Now let's expand the bracket. We have 1 times 6 is 6. 6 times minus cos square theta is minus 6 cos square theta minus 5 cos theta minus 2 equal to 0. So our equation can further be simplified as 6 cos square theta plus 5 cos theta minus 4 equal to 0. Now at this point, our equation looks like a quadratic equation, so we can make simple substitution. So we say let P be equal to cos theta. So we can now express the equation as 6p squared plus 5p minus 4 equal to 0. Now we have to solve the equation using the method of factorization. So we look for two numbers where their sum is equal to plus 5 and their product is equal to negative 24. So the two numbers are plus 8 and minus 3. So our equation becomes 6p squared plus 8p minus 3p minus 4 equal to 0. So at this point, we can factorize. So we have that 6p squared plus 8p. 2p is common, so we have 2p, open the bracket, 3p plus 4. And here we have minus 1, open the bracket, 3p plus 4 equal to 0. So the equation becomes 2p minus 1, close the bracket, multiply by 3p plus 4 equal to 0. So if a multiplied by b is equal to 0, it is true that a is equal to 0 or b is equal to 0. First, we have that 2p minus 1 is equal to 0 or 3p plus 4 is equal to 0. So 2p is equal to 1 if we move 1 to the right hand side, and p is equal to 1 divided by 2. Also, 3p is equal to minus 4, so p will be equal to minus 4 divided by 3. But recall that we said let p be equal to cos theta. Therefore, we can now obtain that for p equal to 1 divided by 2, which is a positive number. So we have that cos theta is equal to 1 divided by 2. Hence, since cos theta is positive, it tells us that the angle lies in either the first quadrant or the fourth quadrant. So for the first quadrant, we have that cos theta is equal to 1 divided by 2, and theta is equal to cos inverse of 1 divided by 2. So therefore, theta is equal to 60 degrees. Also, for the fourth quadrant, cos theta is equal to cos 360 minus theta. So we have this becomes cos 360 minus 60 degrees. So therefore, theta is equal to 300 degrees. Thus, theta is equal to 60 degrees or 300 degrees for 0 less than theta less than 360. Now let's solve question number 5. Question 5 says, given that 4 cos theta plus 3 sin theta is equal to 5, find the value of sin theta, cos theta, tan theta, and cot theta. Solution. The equation given to us is 4 cos theta plus 3 sin theta equal to 5. So we will move 3 sin theta to the right hand side. The equation becomes 4 cos theta equal to 5 minus 3 sin theta. Now at this point, we can square both sides. So we have 4 cos theta all squared equal to 5 minus 3 sin theta all squared. If we simplify, we have 16 cos squared theta equal to 25 minus 30 sin theta plus 9 sin square theta. But recall that cos square theta is equal to 1 minus sin square theta. So our equation can now be expressed as 16 multiplied by 1 minus sin square theta equal to 25 minus 30 sin theta plus 9 sin square theta. At the left hand side, let's open up our bracket. So we have 16 minus 16 times minus sin square theta is 16 sin square theta equal to 25 minus 30 sin theta plus 9 sin square theta. Now let's collect like terms. The equation becomes 9 sin square theta plus 16 sin square theta minus 30 sin theta plus 25 minus 16 equal to 0. So from here, if we simplify further, our equation becomes 25 sin square theta minus 30 sin theta plus 9 equal to 0. At this point, we can express this equation as 5 squared sin square theta minus 30 sin theta plus 3 squared equal to 0. From our knowledge of perfect square, our left hand side can be factorized as 5 sin theta minus 3 all squared equal to 0. Now, if we take the root of both sides, the equation becomes 5 sin theta minus 3 equal to 0. So we have that 5 sin theta is equal to 3 and sin theta is equal to 3 divided by 5. Now at this point we have obtained the value of sin theta. Now to be able to obtain the value of cos theta, tan theta and cot theta, we have to express sin theta equal to 3 divided by 5 in a right angle triangle. So for a right angle triangle, we call this vertex A, vertex B, and vertex C. But we know that sin theta equal to 3 divided by 5, that 3 is the opposite side and 5 is the hypotenuse side. So here becomes theta, and here is 5, which is the hypotenuse side, and 3, which is the opposite side. Now we obtain the adjacent side using the Pythagoras theorem. We have that AC, which is the hypotenuse side, squared is equal to AB squared plus BC squared. So AC is 5 squared equal to AB is 3, which is 3 squared, plus BC all squared. So at this point, we have 25 equal to 9 plus BC all squared. Now, BC all squared, being the subject, can be equal to 25 minus 9. So BC will be equal to root of 16. So therefore, BC is equal to 4. So side BC is equal to 4. So here is equal to 4. So we obtain that I sine theta is equal to 3 divided by 5. So I cos theta will be equal to adjacent divided by hypotenuse, which is 4 divided by 5. Tan theta is giving us opposite divided by adjacent, which is 3 divided by 4. And lastly, cot theta is inverse of tan theta, which is equal to 4 divided by 3. Please, if you know you have found these solutions helpful, like the video and subscribe to our channel. And if you have any question, drop your question in the comment section and I will do a video on that. Thank you so much, and I will see you in the next video. Thank you.